Hey guys, thanks for stopping by. Today's video is about the issue I'm having with my HP-8753A Network Analyzer. This analyzer works well, but the issue is actually with the 85046A S-Parameter test set. This one you see sitting right above the analyzer. It's just a temporary connection. These are all temporary for testing and debugging. Once repaired, it will sit below the analyzer in this position with phase matched cables interlinking both. The one below, this one, is the 8503A S-Parameter test set, which is working well, but it's a manual relay switch between S11 and S22. I was using this because of the issue with the main automatic one. This is automatic. You don't have to do anything. It will switch automatically, whereas here, it has a switch here and it needs AC power. You need to power and then you need to manually switch between the forward and reverse. With the 85046A, which is on the top, I have identified the problem area, and that's the coax relay circuit, which is a common issue with such older equipment. I removed that coax relay. It's a mechanical one. Part number is 5081-8178, 24 volts. DC to 18 gigahertz. The relay tested okay on the bench. Now in circuit, the C terminal, that is the common terminal, does not always get 20 volts. It is just around 12 volts, and that's when the relay coil stopped working, resulting in a failed initialization of the analyzer. When it does get 20 volt, everything works okay. Now let us power it on and see whether it initializes correctly. It did initialize. You see this kind of waveform because I'm just using old cable here for linking both. More than the testing, it is just for debugging. The actual tests, I use better cable than this one, and we get a better waveform. It initialized in front of camera, it initialized, but when this doesn't come, this is somewhere underneath here, and that's when the initialization doesn't work. Now the relay seems to be working, but I have faced such intermittent problems always. Now I need to figure out when and why the 20 volt doesn't appear on the relay coils. Now here is a view of that coaxial relay, this one. So this is the common point, the C, the center one, and then these are the switching between 1 and 2. That means it is just a latching type of relay where the either 1 or 2 gets grounded momentarily and it stays in place. The one which is connected to common is a pass-through, whereas the other one will be connected to a 50 ohm load here, which is inside. I have measured everything. Everything looks okay, and this load also looks okay. So that way it is okay. The continuity between the contacts, common and this one and common and this one, is okay when the relay is working on the bench, and even the relay coil contacts are okay. It is just that in circuit we need to get 20 volts on the common, and that 20 volt doesn't come always. This is the 85046-60001 logic board for the mechanical coax relay, not for the solid state one in the S-parameter box. This card worked okay on the bench. After debug, I found this U3 IC relay driver for the coax switch and for the 70 dB step attenuator is okay. The defective component is actually the big 10,000 microfarad capacitor, which has developed a high ESR, thus not able to supply the required current at the correct voltage for the latching relays to engage. I desoldered U3 and mounted it on a base just in case. As I did not have a 10,000 microfarad at 35 volt or higher capacitor, I used these two good 2200 microfarad 50 volt capacitors, a bit taller, cannibalized from an old HP power supply. The logic board worked well in circuit just with a single 2200 microfarad capacitor, but since I had two, I installed both and secured them to the board using hot glue. Now here's the logic board installed back inside the 85046A. Now my HP-8753A Network Analyzer is back up and running. It has its own phase matched cables interlinking the S-Parameter box. This is the original one. Now this is repaired and is working well. I have done a few tests using this last night. And this older one as a backup, this is not automatic, forward and reverse, and it doesn't have the 70 dB step attenuator inside. Whereas this one is not only automatic for channel 1 and channel 2, that is all the S-parameters, the 4 S-parameters can be measured without doing any manual work. It does it automatically, plus it has the 70 dB step attenuator built in. Everything is kept on a repurposed Tektronix oscilloscope cart, which I modified it for the network analyzer.